So let's try an experiment with the time domain capability of the network analyzer. Now, because of the duality between frequency and time, you can always measure a frequency response of something and convert it into its impulse response or step response, essentially like a TDR. But it doesn't work like a TDR system would. It doesn't actually launch an impulse into the system, but rather it just uses a frequency response here. So in this situation, I have port 1 connected to an adjustable phase shifter. This phase shifter is mechanical, so you can just turn this knob and it will go through the different phases, and it's nothing more than just essentially a delay. On the other side, we have the termination into an open, so we have a complete reflection coming back or a short. It doesn't really matter. So in this situation, if I look at the time domain response of this, I should be able to move the peak of the impulse response as I change the phase over here. And let's try that out. And here are our measurements. At the top, we have the phase of S11. Now keep in mind that this S11 is looking into a short, so its amplitude is going to be constant. We can actually verify that. If you go under the format here and change it to log mag, you can see that we do indeed have essentially almost a perfect reflection, which makes sense. But the phase is going to represent some aspect of the delay and how long it takes for the signal to come back. Let's plot that phase here. Now at the bottom, we're looking at the time analysis of the same thing of S11, and we do have a peak in there, which represents, again, the delay of this entire waveform hitting that short front and coming back. So I'm going to go and adjust the delay, and we should see both of these waveforms move at the same time. Here we go. I'm going to rotate this. And as I rotate, you can clearly see a shift in the phase response, and you can see that peak move. That, of course, the difference between the S11 phase and the impulse should be obvious. They don't move at the same rate, but nonetheless, you can see that this functionality is built into the software. They go all the way to the end of the phase. We've moved it by quite a bit. Now, this is going to be useful if you have imperfections in the line or impedance variations, and the impulse response is going to be different depending on what kind of impedance it's actually seeing. It's a very handy tool, even though it's quite a bit different from TDR and how it is done fundamentally. And the software allows you to mix and match between them. There's also gating capability as well, and in the time domain, there are a few windowing types. I'm just using the normal one, as well as the type is I'm using the low pass impulse. It probably deserves its own video, talk about how time domain in network analyzers work, but some basic functionality is definitely built into this application.